Last topic of this chapter is transmission of power. So how is power transmitted from, one junction to another junction? So here we talk about, again, transformers, step up and step down transformers. So what kind of picture is this? What is this? What do you see here on the screen? Have you seen these kind of poles? What are these poles represent?
Power lines.
Yes, these are power lines, and these are basically, you can see here the line electric wires there. These electrical wires are called transmission lines. Transmission lines, the name transmission lines, it has its, it carries its own definition. We can see the definition in its name only. We can define it easily. Transmission lines. Transmission lines means here wires through which electrical current can be transmitted, or voltage can be transmitted, or anything can be transmitted. So those lines are called transmission lines. Okay, so when we transmit power over long distances, transformers are used to first we step up the voltage at the generator, and then we step it down for use in cities and towns. So first the voltage generated is stepped up, and then it is stepped down. So we use two different transformers, one with the generator where the electricity is produced, and other with the, load where we have to supply the current or electricity. There we place a step down transformer. So the formulas that we are going to use here in this section are these. These formulas we have already discussed. One is of Ohm's law, V is equal to IR. This formula is of power, VI, I square R, V square by R. We know how to connect, root mean square voltage with the peak voltage. Root mean square current with the peak current is 1 by root 2 times the peak current. And ideal transformation ratio this way now. So V1 by V2 is, V1 was that we had taken was the, voltage of the primary coil, and V2 is the voltage of the secondary coil. N1 is the number of turns in the primary, N2 is the number of turns in the secondary. I2 is the current flowing through secondary, and I1 is the current flowing through primary. So here we can see that these two are directly related, while this current is inversely related with the two uh, uh, quantities that we have here, the voltage and the number of turns. Current is inversely related, and voltage and number of turns, they are directly related. So transmission of power. So if even if we have two resistors, when we solve the calculations, we just first, find the equivalent resistance first. We just place one resistance and then we solve the equations. It becomes easier to solve the equations like this. So although the resistance of electrical wires is typically low, so when power lines are run over long distances, this resistance increases because, see, we know this is the resistance of the wire, this zigzag line. We do not put any resistance box or any kind of device there. These are basically the transmission lines that we use, and we know that wires do have resistance, no? Look at this. So these are the lines that I'm talking about. So these lines, these wires have resistance, and that resistance we are representing here by the zigzag line. Okay, so this zigzag line basically represents the resistance of the transmission lines. And we know that resistance is directly proportional to the length of the wire. So if we have, for long distances, the length of the power lines increases, no? And hence the resistance increases, and it results in significant voltage drop and loss in power. Because if the resistance is increased, then there is a voltage drop across it. When current starts flowing, when the current flows in the wire, no? Suppose this is the generator where the electricity is produced, and this is our home where we have to supply the current. So this current has to go through the wire, no, from generator to our home. So this is the transmission line. So the length of the transmission line is quite long, and hence resistance is increased. And because there is significant value of resistance, and what does resistance do? It obstructs the flow of electric current. it resists the flow of electric current. So there is a voltage drop across it, and this results in loss in power, and significant voltage drop across this line. And how can we analyze the transmission of power? A simple power transmission system without transformers, if you do not consider transformers, it consists of a generator and the transmission line and the load. Load can be a single device, load can be a home, a house, load can be whole town, whole city. So load means where we have to, just pass the electric current. Okay, so look at this circuit diagram. So here in this circuit diagram, this SUP represents supply, the voltage supply that we get here from the generator section and the power supply. So this current has to pass through the wire, the transmission line. So we can take, current as I line. Line means current that is flowing through the transmission line or wire. And the resistance of the transmission line can be represented as V line, sorry, R line. R line is the resistance. We write line as a subscript. It is the resistance of the wire. And because of this, we get voltage drop across it, right? So we can write V drop for the voltage drop that occurs here in the transmission line. And see, because let's consider an example. Suppose we have voltage supply equals, let's say 100 volt, and voltage drop is of 20 volt. So what voltage we are going to get at a home or across this load, the load? What voltage are we going to get here? If we are supplying 100 volt and this 20 volt gets wasted while moving from this generator to the transmission line, then the voltage that we get across load would be
80.
Yes, it's 80 volt. Okay, so voltage across load and is represented by V load. And this load can be anything. It can be our home, it can be our city, it can be, any device or anything. Okay. So the transmission system can be represented using a series circuit where the resistance of the transmission lines can be modeled. So with two resistors or with a single resistor. Usually, even if we have, as I had said, even if we have two resistors, when we solve the calculations, we first, get the equivalent resistance and then we solve the calculations. Now look at this. So this is the basic structure of simple power transmission system. It consists of a power supply and the transmission lines and a load. Clear? And because of this, we get the voltage drop across the lines. And because of the high resistance, we get the voltage drop across the lines because length is quite large, So resistance is high. So voltage drop, how do we find voltage drop? This we have discussed already. So this is the power supply, or we get voltage supply here. And how do we, these are the lines, and current I is flowing through these lines, and resistance of the line is R line. So if you have to find voltage drop across the lines, and we can use simple Ohm's law, V is equal to IR here. So voltage drop is equal to I line, R line. This is the voltage drop across the transmission lines. I line is the current in the transmission line, and R line is the resistance of the transmission lines. And how do we find, the voltage across this load? So we can simply, subtract the supply and the voltage drop across the wires to get voltage load. So voltage delivered, this is the voltage delivered. Actually, voltage load is the voltage delivered to the load, right? It is जो deliver हो रही है load को, and it is the difference between the V supply and V drop. Clear? Now, power loss. Because of this voltage drop, we get power loss. No, power loss occurs because of the voltage drop across the transmission lines. So power loss is basically because of the voltage drop, right? And how do we write the formula for power? It is just the product of voltage and current, or we can write I square R for power. So this power loss occurs because of the voltage drop across the lines, and the current flowing through the lines is I line. We write I line for the current which is flowing in the transmission lines, or we can write I line square, and R resistance of the line is R line. And we know that power is measured in watt, and voltage in volt, and current in ampere, resistance in ohm. These are the units that we use. And how do we, calculate or find this power across load if I want to find the power delivered to the load? So power delivered to the load would be the power that we had supplied in the generator, and we'll subtract power loss that occurs in the transmission lines. So on subtracting, you'll get the power that is delivered to the load. So let's do this question now. A generator is producing 200 watt at 40 volt RMS. So RMS value of voltage is given. RMS value of voltage, this value we supplies in RMS, root mean square voltage, which is used to supply a food truck. The transmission lines have a resistance of 1 ohm each. See, we can redraw the circuit. We can redraw the circuit as this. This is the supply. We can write V supply here, SUP. It's 40 volt, and power supply is 200 watt. And this is the resistance. We have two transmission lines have a resistance of 1 ohm each. So we can collectively write them as 2 ohm. And we are going to collect this voltage across the load. We can write load here. So 200 watt and 40 volt is given. So from these two, we can get the value of the current flowing in the transmission line, because P is equal to VI. This is the formula. From here, we can get the value of I as P upon V. So we'll get current like this. What value you're getting? 200 divided by 40. It's 5 ampere. So 5 into 2, it's 10 volt. Okay, so 10 volt is the voltage drop. And so voltage across load would be V supply minus V drop. No? It is V supply minus V drop. So just subtract these two, 40 volt minus 10 volt, you'll get 30 volt as the voltage across load. Power loss is I square line and I line square and R line. I line is the current which is flowing in the transmission line, and R line is the resistance of the transmission line. So we can find power loss like this, put the values here. 5 ampere is the current, and resistance of the transmission line is 2 ohm. Just multiply these two and you'll get 50 watt as the power loss. Clear? And in the next question, we have to find the power delivered. So the power supply is 200 watt and power loss is 50 watt. So we can find power load. The way we find for voltage, in the same way we can find for power. So if in the supply section we have a power of 200 watt, and across this load the loss is 50, then what power do we expect that would be delivered here in the load? 50 is the loss. It has gone, vanished. Now the remaining power is 150 watt.
150.
Yes, we can simply subtract power supply and power loss to get power load. Okay, so subtract these two and you'll get power load as 150 watt. Yes, now look at this question. A 30-volt RMS voltage is given, a voltage supply is given, and it is used to deliver 300 watt of power to a circuit. The resistance of each transmission line is 1 ohm, so total resistance is 2 ohm. So what is the current in the transmission lines? See, for the current in the transmission line, uh, we can use the formula P is equal to VI, and I line is power supply divided by voltage VRMS. So power supply divided by VRMS, just subtract these two. So 300 by 30. So you'll get 10 ampere as the current that would be flowing through this transmission line. So 10 ampere is the correct answer. Which of the following is the correct voltage drop and power loss? See, for voltage drop, V drop we have to find out. So V drop is I line, R line. So I line is 10 ampere and resistance of the transmission line is 2 ohm. So voltage drop is 20 volt. 20 VRMS is the voltage drop. And power loss? Power loss कैसे find करेंगे? Power loss is I line square R line. And I is 10 ampere, so 10 square into resistance of the transmission line is 2, so it's 200 watt. So this is the correct option. Any doubt in this? Any doubt in this?
मैम हम P loss V drop और I line को मल्टीप्लाई करके भी निकाल सकते हैं
P loss, V drop और I line को हाँ जी निकाल सकते हैं. देखो क्योंकि आपके पावर के we have 3 different formulas, right? एक तो VI, एक I square R और एक V square by R. You can use any formula. Okay? जो भी आपको quantities given है, accordingly you can use the formula. Next, how can a transformer reduce power losses in transmission lines? Now, the purpose of transformers. Why do we use transformers? Abhi tak we have not used transformers in the transmission lines. We had, simply a generator, and generator is used to produce the electric current and the transmission lines and the load. This we had done. Now we are going to use transformers in the transmission lines. And what is the purpose of using transformers in transmission lines? It reduces the power loss. The power loss that we get, we have calculated the power loss, the voltage drop across the lines, right? So we can, reduce the voltage drop, we can reduce the power losses in the transmission lines by using transformers. So here we're going to use two transformers. One is step up and other is step down. So we use step up transformer with the generator, and we use step down transformer with the load. What is the difference between step up and step down? What does
step
a
up increases the voltage and step down decreases the voltage
Yes, step up transformer increases the voltage and step down transformer decreases the voltage. So first we increase the voltage and then we decrease the voltage. Clear? And in step up transformer, we have number of primary turns less than secondary turns. Number of turns in secondary coil is greater than number of turns in primary coil, while in step down transformer, number of turns in primary coil is greater than number of turns in secondary coil. So by using a transformer, see, These are the advantages that why do we use transformers in transmission lines. They can ask you in the exam if they ask any theoretical question or concept based questions. So the current can be decreased in the transmission line by stepping up the voltage. So if we step up the voltage in the step up transformer that we are using with the generator, then current can be decreased, that is passing through the transmission lines. It decreases the current in the transmission lines. This is the first advantage of using transformers in the with the transmission lines. Second, because the current is reduced, so voltage drop gets reduced. Because see, we cannot change the resistance of the transmission lines, right? The length of the transmission line cannot be decreased or increased. We need जितनी चाहिए उतने required line, उतनी length को हम change नहीं कर सकते, right? But we can change the current and the voltage. So because of the decrease in the current in the transmission line, voltage drop across the transmission line will decrease. And because voltage drop across the transmission line is decreased, now we get more voltage across the load. Because what is V load? V load is V supply minus V drop. The voltage that has been supplied in the generator and the voltage drop that occurs across the transmission lines. When we subtract these two, we get voltage across the load. Right? So if we decrease the voltage drop, if we decrease this value, if this value is decreased, then V load will increase. So by reducing the voltage drop, we can increase the voltage across load. Are you getting what I'm saying? Third, this power loss, the power loss in the transmission lines is significantly reduced because I is reduced, V is reduced, and what is power loss? Power loss is nothing but V drop I line, no? The formula for power loss is V drop, the voltage drop across the low transmission lines, I line. So if both the values are decreased, current is decreased, voltage is decreased, voltage drop is decreased, then automatically power loss is also decreased, significantly reduced. This improves the overall efficiency of the power transmission system. So if there are less power losses, then we get the same power, nearly the same power as that of the generator. Because how do we write for power? See, if this is the power supply that we have here in the generator, so power loss occurs here in the transmission lines and we get power across the load. So power across the load, again, as we write for voltage, in the same way we write for power. So power that is delivered to the load is the power supply minus power loss across the, because of this voltage drop, we get the power loss. Because of this voltage drop, we get the power loss in the transmission lines. So the power that is delivered is less as compared to the power that has been supplied. So if there are less power losses, then the power that is delivered to the load would be same as the power that has been supplied from the generator. So we can say that transformer, it's the power, because there are no power losses means 100% efficiency or nearly 100% efficiency or good efficiency, we can say. Not 100% is practically not possible because that's the case of ideal things. Ideal things are not practically possible, no? So in 6B, we had done that same amount of power can be transmitted using different combinations of current and voltage. So when we step up the voltage, current is reduced by the same factor. Therefore, power transmitted remains the same. Using lower current, greater voltages is preferred on long distances. Yay. This thing. I'm going to clear it. Lower currents and greater voltages is preferred in long distance power transmission for the sake of reducing the voltage drop and the power loss in the transmission lines. You can write this wherever you want, or you can mark a star here. They can ask you questions based on this, conceptual questions.
Can you explain this? Can you explain this?
For example, this is your generator and this is our home and these are the transmission lines. So if we add a step-up transformer here, so what happens is that it increases the voltage. And the relation that we know is V1 by V2 is equal to N1 by N2 is equal to I2 by I1. So you can see voltage and current are inversely related. So if voltage is increased, then I line will decrease. Right? And if I line is decreased, then because I line is decreased and what is voltage drop? Voltage drop is I line, R line, Ohm's law. So if I line is decreased, then V drop, voltage drop across the lines will decrease. So lower currents. So we are decreasing the current. In long distances, we are decreasing the current. Why are we decreasing the current? To decrease the power losses. Because if the voltage drop is decreased, so power loss is also decreased because power loss is nothing but V drop I line. Because current is decreased, so the voltage drop is decreased, and because the voltage drop is decreased and power losses are less. Okay, so in long distances, we prefer lower values of currents. Why? For the sake of reducing the voltage drop, because we want to reduce the voltage drop and we want to reduce the power loss in the transmission lines. नहीं आया.
आ गया समझ.
So we can, basically change the ratio of currents and voltages to suit each stage of the transmission system. These are the ratios that we are taking here. No? So we use a step-up transformer between the power supply and the transmission lines. This is the power supply and this is the transmission lines. So between these two, transmission line and the generator, we use a step-up transformer. And second, we use a step-down transformer between the transmission line and the load. This is the load, our home. This is the load and this is the transmission line. And between these two, the transformer that we use is step-down. Clear? Should I clear the screen?
Yes.
So this is the basic, structure of power transmission we have step up and step down transformer here. So you can see in step up transformer, this is the primary coil and this is secondary. In secondary coil, we have more number of turns because this is step up. And in step down, we have more number of turns in primary than secondary.
Why do we have more number of turns in primary than in secondary?
To collect the load because number of turns increases the EMF induced.
Oh, okay.
E is minus n delta phi by delta t. So if we have more number of turns, then more EMF will be induced and more current will be produced. In step up, we need more voltage, right? And therefore, we place more number of turns in the secondary coil to collect more voltage. And this is the circuit diagram for this. Look at these two. You can compare easily. So the power supply is drawn like this, a waveform, because this is an AC supply. And for AC supply, this is the symbol. So this is V supply. And from V supply, we get the current I supply in the primary coil of the transformer. Look at the structure, please. So this is the primary coil. So from V supply, now we are using I supply. Initially, we had just written I line. We had one common current, I line. But now we are decreasing or increasing the current. So we have different values of current that we're going to get here. So one current is the current that has been supplied from this V supply. The current I supply is there. and this current goes to the primary coil of the transformer, step up transformer, and this current goes to the primary coil of step up transformer. Now this step up transformer increases the voltage, right? Step up the voltage. So the step up voltage V2 step up is written there. You can see the voltage that we collect here at this point is the V2 step up voltage. This step up voltage is the voltage that we collect across the secondary coil of the step up transformer. This is your V supply. V supply, and the current is I supply. Okay, and this I supply goes to the primary coil of the transformer. And here, because this is a step up transformer, so the value of the current will change. So the voltage that we get across this point, no, this is the output. ये step up है. तो जब इसके primary coil में V supply गया, primary coil में जो current है I supply गया, तो ये step up transformer है. तो सेकेंडरी कॉइल के अक्रॉस आपका वोल्टेज और करंट चेंज हो जाएगा. द वोल्टेज एंड करंट विल चेंज across the secondary coil. So now the voltage is V2 step up. So from V supply, the voltage becomes V2 step up. Why are we writing V2? Because we are getting this voltage across the second coil, the secondary coil, and step up of the step up transformer. And the current now is I line. Current was I supply earlier. Now the current is changed to I line. Now this current is flowing through this transmission line, and in this transmission line voltage drop will occur, right? Because we have resistance of the transmission line, significant resistance of the transmission line, and because of this voltage drop across the transmission line will occur. So this is the voltage drop, and because of the voltage drop, now the voltage is different. So initially it was V supply, then it became V2 step up. Now because of this voltage drop, the voltage will change, and the voltage that has been collected now across this another transformer, the step down transformer, the primary coil of the transformer, would be because we are getting this voltage in the first coil, right? The primary coil is the first coil of step down transformer, and that's why we are writing the subscript V1, because first coil, the primary coil, comma, step down. We write like this. Okay, and this is the step down transformer. So again, the current is I line and voltage is V1 step down. So it will pass through the primary coil of the step down transformer. So the voltage and current that will collect across the secondary coil of the step down transformer would be I load. The current, we are writing current as I load, and the voltage we are writing as V load. So this is what is happening here. So we have so many, notations here. So we need to understand that how the current is changing, how the voltage is changing, what is happening in the primary coil and the secondary coil of step up and step down transformers respectively. Is this confusing, or should I explain it again, or can we discuss the questions based on this? What should we
Can
do?
you explain it again?
देखो, इसको कुछ नहीं है बेटा इसमें. यहाँ देखो मेरी तरफ. आपके पास, अब बहुत ध्यान से सुनना, ठीक है? मैं आपको बिल्कुल इजी लैंग्वेज में आराम से समझाऊंगी. जनरेटर से करंट आ रहा है, वोल्टेज आ रही है, ट्रांसमिशन लाइन में जा रहा है, ट्रांसमिशन लाइन में रेजिस्टेंस है, तो रेजिस्टेंस के अक्रॉस वोल्टेज ड्रॉप हो रहा है, पावर लॉस हो रहा है, सब कुछ हो रहा है, हमें उसको प्रिवेंट करना है. तो जितना हम ट्रांसमिशन लाइन से करंट को कम पास करेंगे, उतना ही पावर लॉस और वोल्टेज ड्रॉप कम होता है. ठीक है ना? तो अब हमें वोल्टेज और करंट को कम कैसे करें? वोल्टेज करंट को हम कैसे कम करेंगे? यहाँ पे जनरेटर है, यहाँ पे हमारा घर है, ये हमारी ट्रांसमिशन लाइंस हैं. ठीक है, अब जितना ज्यादा इसमें से करंट जाएगा उतना ही इसमें वोल्टेज ड्रॉप हो रहा है, उतना इसके रेजिस्टेंस है, क्योंकि इसकी सिग्निफिकेंट रेजिस्टेंस है. रेजिस्टेंस को हम चेंज नहीं कर सकते ना. आप ट्रांसमिशन लाइन की लेंथ थोड़ा कम करोगे, ट्रांसमिशन लाइन की जो लेंथ है वो तो उतनी ही रहेगी, उसको हम कम नहीं कर सकते हैं। तो बिकॉज यहाँ पे रेजिस्टेंस के चक्कर में ना यहाँ पे करंट जो है वो जो फ्लो कर रहा है, तो अच्छा खासा ठीक ठाक वैल्यू वोल्टेज की जो है वो ड्रॉप हो रही है। तो इसके लिए हम क्या कर रहे हैं, हम ट्रांसफॉर्मर यूज कर रहे हैं कि पहले हम स्टेप अप करते हैं और फिर हम स्टेप डाउन करते हैं। अब स्टेप अप ट्रांसफॉर्मर से क्या होता है कि जब आप यहाँ पे स्टेप अप ट्रांसफॉर्मर लगा दिया आपने, तो उससे क्या होगा कि जो वोल्टेज है आपका वो इंक्रीज हो जाएगा, है ना। स्टेप अप का काम है वोल्टेज को इंक्रीज करना। अब जो आपका रिलेशन आपने ट्रांसफॉर्मर में किया था उसमें क्या था, आपका V1/V2 जो है वो I2/I1 है, इनवर्स रिलेशन है उसमें, है ना। और एन के साथ आपका डायरेक्ट रिलेशन है, मतलब नंबर ऑफ टर्न्स का और वोल्टेज का तो डायरेक्ट रिलेशन है, बट करंट के साथ इनवर्स रिलेशन है। ट्रांसफॉर्मर में हमने ये किया था। तो अगर हम स्टेप अप ट्रांसफॉर्मर लगा रहे हैं तो हमारा वोल्टेज इंक्रीज हो रहा है। वोल्टेज इंक्रीज होने से ना हमारे करंट की वैल्यू जो लाइन में से पास करेगी ना वो कम हो गई, और क्योंकि करंट की वैल्यू कम हो गई तो लॉस कम हो गया, पावर लॉस और वोल्टेज लॉस, ये तो समझ आ गया था आपको। अब ये जो अब जो इसकी बात करते हैं, जो इतने सारे हमने बहुत सारी चीजें लिख दी हैं यहाँ पे जो कंफ्यूज कर रही है हमें, इसको ना, इसके नोटेशंस को, आर लाइन, आर सप्लाई, स्टेप अप, स्टेप डाउन, ये इनको सबको देख के आप डरो मत कि ये क्या लिखा हुआ है। क्योंकि आपको लग रहा है अरे इतने सारे सिंबल्स, ओ माय गॉड, मतलब वी सप्लाई भी करें, फिर आई सप्लाई, फिर V2 स्टेप अप क्या हो रहा है, आई लाइन क्या हो रहा है, वी ड्रॉप है, फिर I1 स्टेप डाउन है, फिर वी लोड है, ये क्या हो रहा है हमारे साथ। उसको देख के डरो मत, वो पैनिक क्रिएट कर रहे हो, कुछ नहीं है, ये है कुछ भी नहीं इसके अंदर। आपने क्या देखना है, आपने बस ये देखना है कि पीछे से आपकी जो सप्लाई वोल्टेज है, तो उसमें से जो करंट आ रहा है वो आई सप्लाई आ रहा है। अब दिस करंट विल नॉट गो डायरेक्टली टू द ट्रांसमिशन लाइन। ये करंट ट्रांसमिशन लाइन में डायरेक्टली नहीं जा रहा है, ये दिस करंट हैज टू गो थ्रू द ट्रांसफॉर्मर एंड देन इट विल गो टू द ट्रांसमिशन लाइन। ऐसे ही हो रहा है ना। तो पहले ये ट्रांसफॉर्मर में जाएगा, अब ट्रांसफॉर्मर में कहा जाएगा, ट्रांसफॉर्मर की प्राइमरी कॉइल में जाएगा। ऑब्वियस है, जब आप करंट को प्राइमरी कॉइल में डालोगे तो उसका वैल्यू चेंज हो रहा है, बिकॉज आप स्टेप अप ट्रांसफॉर्मर में डाल रहे हो उसको, करंट को, तो उसका करंट का वैल्यू, वोल्टेज का वैल्यू चेंज होगा ना। नहीं होगा क्या? होगा। तो जब आपने उसको प्राइमरी कॉइल में आपने वी सप्लाई आई सप्लाई डाला, तो वी सप्लाई आई सप्लाई प्राइमरी कॉइल में गया, तो स्टेप अप ट्रांसफॉर्मर है, तो सेकेंडरी के अक्रॉस जो आपको आउटपुट मिलेगा वो नहीं मिलेगा जो आपने डाला है। वो आपको मिलेगा जो आपका आई सप्लाई है, जो आपने प्राइमरी कॉइल में डाला था, वो बन गया आपका आई लाइन। आई लाइन क्यों बोल रहे हैं, क्योंकि अल्टीमेटली अब ये करंट, दिस करंट हैज टू पास थ्रू द ट्रांसमिशन लाइन, दैट्स व्हाई वी आर यूजिंग दिस आई लाइन सबस्क्रिप्ट। ठीक है। क्यों, अगर हम इसको I1 I2 I3 I4 लिखेंगे तो हम खुद कंफ्यूज हो जाएंगे कि यार कौन से वाला 2 था, कौन से वाला 3 था। तो बेटर है ना कि पूरा लिखते हैं। सप्लाई लिखते हैं, ठीक है, सप्लाई का करंट है, ये पीछे से आ रहा है, और आई लाइन लिखते हैं, ठीक है, कि ट्रांसमिशन लाइन से पास कर रहा है। ठीक है, तो हम इसको आई लाइन लिखते हैं। इजी, इजी हो जाएगा ना अंडरस्टैंड करना। I1 I2 I3 तो कंफ्यूजिंग है, कौन सा I2 है कौन सा I3 है हम भूल जाएंगे। तो अभी जो आपका वी सप्लाई है, द वी सप्लाई, दिस वी सप्लाई, ये जो जनरेटर में जनरेट हो रहा है, when this V supply passes through the step up transformer, its value will change as well. तो जो voltage that you are going to collect in the secondary coil would be different, no? अगर आपका I supply I line में convert हो रहा है, तो आपका जो V supply है वो भी तो आपका V कुछ में convert होगा। और V कुछ, what we are writing for V कुछ, we are writing V2, Y2, because this is a secondary coil, secondary, second 2 लिख दिया हमने, ऑफ स्टेप अप, कॉमा स्टेप अप लिख दिया, इजी हो गया, ठीक है, सेकेंडरी कॉइल ऑफ स्टेप अप में कलेक्ट हो रहा है ये। ठीक है, इतना आ गया। ओके। अब नाउ दिस करंट एंड वोल्टेज, दिस थिंग इज पासिंग थ्रू द ट्रांसमिशन लाइन। So transmission line has its own significant resistance, right? So voltage drop will occur across the transmission line. ट्रांसमिशन लाइन के अक्रॉस वोल्टेज ड्रॉप होगा या नहीं होगा? तो जब ट्रांसमिशन लाइन के अक्रॉस आपका वोल्टेज ड्रॉप होगा तो वोल्टेज विल चेंज नाउ, क्योंकि आपका वोल्टेज ड्रॉप हो गया। तो इनिशियली इट वाज V सप्लाई, देन इट बिकेम V2 स्टेप अप, and when it passes through the transmission line voltage drop occurred, and because of that voltage drop again the voltage will change. Now the voltage that is there in the primary coil of step down transformer, we can write that voltage as V1 step down. and this voltage now is passing through the primary coil of the step down transformer, and from step down transformer again the voltage will change. दो ट्रांसफॉर्मर है ना, पहले इंक्रीज किया, नाउ विल डिक्रीज इट. अभी द वोल्टेज दैट वी आर गोइंग विल गेट, ये जो वोल्टेज है लोड वाला जो घर में जाएगा पास होगा, दैट्स वी लोड. So this is how voltage is changing from step up to step down transformer. And how the current is changing? So current was initially I supply, then the current passes through the line, the transmission line, and then current changes to load, I load. So this is how current is changing, this is how voltage is changing. So you can also find voltage drop by subtracting these two. You just have to, understand the concept. और फिर आपने बॉदर नहीं करना, कोई मर्जी क्वेश्चन आ जाए आपको फर्क नहीं पड़ता उससे. Okay, so these are the formulas that you can see here for step up and transformer. So we know that the relation, right, of transformer, it's V1 by V2 equals N1 over N2 equals I2 over I1. This is the relation that we use, right? Now for step up transformer, this is the, I supply, V supply we get here. In the primary coil, I supply, V supply we have, right? And in the secondary coil, we get I line and V2 step up voltage. This is what we get, right? So the way we relate the current and voltages and number of turns in the primary and secondary, we can apply this relation here as well using the same notation, because in the step up transformer reason we have N1 less than N2 because number of turns in secondary coil is greater than number of turns in primary coil. So N2 is greater than N1. So N1 by N2 would be N1 by N2 would be I line, because this is the current passing through secondary and this is the current passing through primary. And the current passing through secondary we're taking as I line, and through primary it is I supply. So we can write I line upon I supply, right? Is this clear? Same we can apply for voltage. These are directly proportional. So N1 by N2 can be written as N1 by N2 is V1 is V supply, the primary current voltage in primary, and V2 is V2 step up. So in place of V1, we can write V supply, and in place of V2, we can write V2 step up. And we are assuming power to be same because we are considering that there is no power loss across the transformer. We're considering the ideal conditions. And formula for voltage drop across the line, this we have discussed already. I line, R line, and power loss. We use this formula for power loss. Clear? And in case of step down transformer, for step down transformer, this is the current, I line is the current, and we get the current across the load as I load. We write this as I load, right? And the voltage that we get here is V2 step up is the voltage, and here the voltage is V load. So we can relate these things accordingly, right? ये explain करना पड़ेगा, मुझे लग रहा है इसका need है ना? थोड़ा confusing लग रहा है ना? बताती हूँ. Actually इसमें diagram चाहिए मुझे सामने, and we do not have this diagram here, so slightly. ये है. So यहाँ पे है हमारा V supply, I supply, और इधर ये आपका V supply I supply आएगा. इधर आपका जो करंट है ये बन जाएगा I line, और वोल्टेज बन जाएगा V2 स्टेप अप. अब इधर करंट जाएगा और यहाँ पे रेजिस्टेंस है आर लाइन और इसके क्रॉस होगा वोल्टेज ड्रॉप, और फिर यहाँ पे वोल्टेज आएगा आपका V2, सॉरी नॉट V2, V1 स्टेप अप, सॉरी स्टेप डाउन, V1 स्टेप डाउन, और यहाँ पे वोल्टेज आएगा V ड्रॉप, V लोड, और आई लाइन है और यहाँ पे करंट आएगा आई लोड। इसके ट्रांसफॉर्मर्स के अंदर कोई पावर लॉस नहीं है, बट लाइन में तो पावर लॉस है ना। यहाँ देखो, ट्रांसफॉर्मर्स में पावर लॉस नहीं है, बट जो ट्रांसमिशन लाइन है वहां पर तो पावर लॉस है ना, क्योंकि वहां वोल्टेज ड्रॉप हो रहा है तो वहां पावर लॉस कुछ तो होगा, ऐसा तो नहीं है कि वोल्टेज ड्रॉप जीरो है। तो यहाँ पे वोल्टेज कम है और यहाँ वोल्टेज ज्यादा है, तो अगर हम V2 स्टेप अप में माइनस करेंगे V ड्रॉप, देन वील गेट V1 स्टेप डाउन। अगर सपोज यहाँ पे आपने वोल्टेज कलेक्ट किया लेट से 10 वोल्ट एंड ड्रॉप हुआ 2 वोल्ट का, तो जो V1 में जो स्टेप इस वाले जो इसके प्राइमरी कॉइल में वोल्टेज जाएगा वो 8 वोल्ट का जाएगा। नहीं आया?
आ गया समझ में।
जैसे यहाँ पे अगर आपका V2 स्टेप अप 10 वोल्ट है और ड्रॉप हुआ 2 वोल्ट का, तो जो प्राइमरी में वोल्टेज आएगा वो 8 वोल्ट का। कैसे आया? इन दोनों को माइनस करेंगे तो आएगा ये। तो आपने V2 स्टेप अप में से वोल्टेज ड्रॉप को माइनस किया तो V1 स्टेप डाउन आ गया, दिस रिलेशन। अब बताओ। हम्म, इकरा मुझे ब्लैंक लग रही है अभी भी।
नहीं मैम आ गया।
चलो ओके। और यहाँ पे आपका है पावर लॉस भी है, ठीक है। तो इधर आपका जो पावर है सेकेंडरी में, वी आर टेकिंग दैट पावर एज P2 step up. Across the secondary coil, the power that we are getting is P2 step up, and across the primary coil, the power that we are getting is P1 step down. ये प्राइमरी कॉइल में है ये, और ट्रांसमिशन लाइन के अक्रॉस पावर लॉस हुआ है, तो इसमें से पावर लॉस को माइनस करेंगे ना, ट्रांसमिशन लाइन के अक्रॉस जो पावर लॉस हुआ है उसको जब माइनस करेंगे तो P1 स्टेप अप विल गेट, मतलब ये P1 स्टेप डाउन मिलेगा तब। नहीं आया? P2 स्टेप अप में से अगर हम पावर लॉस करेंगे तो P1 स्टेप डाउन आएगा, और जो P1 स्टेप डाउन है क्योंकि ट्रांसफॉर्मर के अक्रॉस पावर लॉस नहीं हो रहा है, वी आर अज्यूमिंग ट्रांसफॉर्मर्स की आइडियल है वो, तो अगर यहाँ पे पावर आपका P1 स्टेप डाउन है तो आपके ट्रांसफॉर्मर के क्रॉस तो पावर लॉस हो नहीं रहा है, तो जो लोड के क्रॉस जो पावर आएगा वो भी P1 स्टेप डाउन ही आएगा, सेम। पावर लॉस
आ गया।
ट्रांसफॉर्मर्स में नहीं है, पावर लॉस ट्रांसमिशन लाइन में है। ओके। और N1/N2 तो पता ही है आपको, इधर नंबर ऑफ टर्न्स का और वोल्टेज का कैसा रिलेशन, डायरेक्ट रिलेशन होता है। तो N1 इज द नंबर ऑफ टर्न्स इन द प्राइमरी कॉइल एंड वोल्टेज अक्रॉस प्राइमरी कॉइल इज V1 स्टेप डाउन, एंड नंबर ऑफ टर्न्स इन सेकेंडरी कॉइल इज N2 एंड वोल्टेज अक्रॉस सेकेंडरी कॉइल इज V लोड। ठीक है। और करंट का इनवर्स रिलेशन होता है, तो अगर आप N1/N2 ले रहे हो तो प्राइमरी कॉइल के नंबर ऑफ टर्न्स अगर N1 है तो सेकेंडरी कॉइल का करंट लोगे। नहीं आया समझ? प्राइमरी कॉइल के नंबर ऑफ टर्न्स अगर N1 है तो सेकेंडरी कॉइल का जो करंट है वो आई लोड है, विल राइट आई लोड इन द न्यूमरेटर। और प्राइमरी सेकेंडरी कॉइल के नंबर ऑफ टर्न्स अगर N2 है तो प्राइमरी कॉइल में करंट कितना फ्लो कर रहा है, प्राइमरी करंट में करंट फ्लो कर रहा है आई लाइन, जो ट्रांसमिशन लाइन में फ्लो कर रहा है। आया या नहीं आया?
आ गया। ओके।
चलो ठीक है, आई एम गोइंग टू क्लियर द स्क्रीन नाउ। मीटिंग इज विल एंड इन 8 मिनट्स। अब ये क्वेश्चन है वर्क एग्जाम्पल 2, तो नाउ यू कैन सॉल्व दिस क्वेश्चन, थिंग्स आर गिवन, तो अकॉर्डिंगली यू हैव टू फाइंड द रिमेनिंग थिंग्स जो उसमें आपको पूछा होगा। ठीक है, तो आपको इसमें क्या गिवन है, लेट्स फाइंड आउट। Consider the power transmission system used to supply the food truck from worked example 1. The same generator 200 watt 40 volt RMS value given है आपको, ये आपको दिया हुआ है. So this is your V supply, P supply is used in the same transmission line 1 ohm. So resistance is 2 ohm and ratio is 1 is to n. 1 is to n means we have n1 by n2. N1 by n2 is 1 by 10 for primary coil because we have less number of turns in primary. And to reduce the power losses, the owner installs a step-up transformer with a 1 is to 10 turns ratio between the generator and the transmission lines, and a step-down transformer with a 10 is to 1 ratio between the transmission lines and the truck. Fine. So model the electrical circuit shown in the circuit diagram. The clarity hai hame. This is how we can draw the circuit diagram for the above. Right? We'll just place one supply here and the transformer, the step up and the step down. Ratio indicates the number of turns. Ratio, R line is 2 ohm, and we are going to collect the voltage across the load. Next is calculate the current in the transmission line. So for current in the transmission line, we have to find I line, no? Beta आवाज नहीं. I line calculate कैसे करेंगे? आपको P supply, V supply given है. तो P supply, V supply से we can find I supply. And we can relate number by number with the number of turns. So number of turns are given n1 by n2. So number of turns and current are inversely proportional. So number of turns in primary is n1. So we'll take current in secondary, I line. And number of turns ये secondary के हैं, so we'll take current in primary, I supply. This is how we relate with the ratio, no? So first we will find I supply using this formula, P is equal to VI. So from here we'll get the value of I supply. It's 5 ampere we're getting. And then because N1 by N2 is given, it's 1 by 10. And I supply is 5 ampere. So we can find the current, flowing in the transmission line using this relation. Just cross multiply them and you'll get the value of current, 0.5 ampere. So you can see that initially we had 5 ampere and now it has become 0.5 ampere. From 5 to 0.5 because it is step up transformer. So voltage is increased and current is decreased. And now we can also find the voltage drop across this load. And from voltage drop, you will get the voltage across the secondary that is passing through the primary coil of the second transformer that we have here, step down transformer. No? Calculate the power loss in the transmission lines. For power loss, we'll use the relation because power loss is occurring in the transmission line, and in the transmission line current is I line and resistance is R line. So just put the values here and you'll get the power loss. Okay, so we need to understand the concept. Once the concept is clear, notations are clear, we can easily solve any question.
अगर इसमें हमें करंट जो है वो आरएमएस वाला दिया होगा तो वी हैव टू कन्वर्ट इट और नॉट?
By default we assume the current to be in RMS.
Okay.
No, we don't convert. If they ask you to find peak current, only then you convert. If they ask you something like this, only then you convert. Otherwise, take the current as it is given to you.
So ma'am, the purpose of RMS current is so that it is equal to the DC current, right?
Yes, because we can connect any appliance with a, if I have an appliance, so I can connect that appliance with a DC source or an AC source. So we just take RMS value of voltage or current in AC. That is equivalent to DC. Calculate the power delivered to the food truck. See, for the power delivered to the food truck, we need to find power load, right? So power load is P supply, that the power that has been supplied, and we'll subtract, power loss from it. Power loss we have calculated in the previous section. We just have to subtract and you'll get the power load. Okay. We have actually so many notations, but the concept is simple. But if the concept is clear, then notations, they do not matter at all because we know what we're doing, right?